Hi everyone, my name is Milad and I am going to be doing a system design practice exercise. I'm doing these to improve my skill set and hopefully in the process you guys learn something as well. Remember, always double check anything you hear or see in my videos. These are exercises I'm doing on the fly and there might be inaccuracies in them, so be sure to double check everything you hear. If you do enjoy the video, please take a moment to like, subscribe, and comment. Alright, with that said, let's jump right into it. So today we'll be designing Twitter. What we want to do is handle over 5 million tweets and 300 plus million active users per day, support for high volume real-time tweet processing, search functionality for tweets and hashtags, integration of media content such as images, videos, and tweets, implement timelines with personalized content feed. All right, so what I'd like to start off with is getting our database schema out of the way. And I will be limiting the schema to what we'll be trying to accomplish here. It could always grow much more. So we'll start off with the user table. We'll have user ID, username, status. Okay. And date stamp, just some standard information. And there can always be additional metadata there. User tweet. User tweet ID, user ID, text, date stamp, and status ID. So this table will hold the tweet the user has posted. Let's see here. User tweet like. This is if somebody liked the tweet. And we'll do user tweet ID and user ID. We'll make this as the primary key. This means you can only like a tweet once. You can do other things like repost, and let's do user tweet comment, and this will be user comment ID, the primary key, user tweet ID, the tweet that this comment belongs to, user ID, the user who posted this comment, and then let's see the text, the actual comment, date stamp, status ID, and then we can also have user tweet comment like, user tweet comment ID, oops, yeah, that's what we want, and user ID. All right, and then if we can also have a reply here. Well, let's just keep it simple here. You can simply comment here and we'll keep it at that. The next thing we want to do is user tweet media, user tweet media ID, and then what we want, this is where if a user uploads an image or let's say an audio file or a video file, it will be saved here. At least the data about that media will be saved here. It'll be user ID, media type ID. This will tell us what type of media it is. We will have URL, the location of this media, and then date stamp. The most important thing here, user tweet ID. All right, let's take a look at here. Look at this. Okay, this will basically allow us to thing, and we also want to do some hashtags, user tweet hashtag. So is that what we want to do? Hashtags, yeah, hashtags, user tweet hashtags, and then user tweet ID, and then hashtag. Let's just do text. If we want to create a library, we can make this hashtag ID, which means that they're selecting from a predefined hashtag that's in a library. So there are many ways you can do it. For now, I'll just take this into account. So that's our database schema. Remember, this is the very basic. There's other information like password, email, a whole bunch of other things, but for now, that's all we'll be doing. All right, now let's take a look at the APIs. What I'm doing is ignoring basic API that you'll find in any online application, like login, forget password, and all those other things. So we'll just keep it to that. So we'll do a post tweet. We'll pass access token. The system will use that to determine who the user is. We will provide the text, and we will provide media, and this could be a list, and then that should be good enough for that. Let's see, I'm writing something, posting it. Okay, that sounds good. Let's just say we won't have an update here. Either you post a tweet or you delete it. Delete. We'll do another post, tweet, delete. Here we'll have access token again. We'll have user tweet ID. All right, so now what we want to do is also post tweet like, basically same thing. Access token, user tweet ID. I'm going to need this again. So when you like it, whether you're liking it once or clicking on it to unlike it, the system, the client, and the backend will know how to handle this. This is just some simple logic. If it's already liked and you click on it, it'll send the ID there, and the system will know that if it exists, delete it. And we want to do post tweet comment. Text. And for now, we're going to keep it simple. Let's just say when you're commenting, you can't post images. Otherwise, we'll have to extend our database schema. And let's see. Okay, so we commented. Is there anything else we need to do here? Nope. I think that is pretty much it. Yeah, let's do one other thing. Delete. Actually, we're going to update this to be a delete instead of a post. Tweet, comment, delete, and then access token, tweet, comment ID. All right. And one other thing we need here is user comment like. So tweet, and we'll post this when we want to like something. All right, that should do it for our API endpoints. Okay, so let's move these things over here. And let's talk about our system. Massive system. We're dealing with 5 million tweets per day, 300 million active users every day. We're definitely going to be using load balancers here. We'll start off with global load balancers. They are used to determine where to direct you, what region. They keep track. If one region goes down, they'll figure out what other region to direct you to. And then once the global load balancer knows what region to send you to, we'll go to the regional load balancer. In here, we'll implement a variety of potential algorithms depending on what we deem most appropriate. The way you make these decisions are really understanding your clients, the distribution of the traffic, and how your system is designed. You can do round robin, least connection, least volume, weighted round robin. So there are a lot of ways you can approach this. Given the volume of users we have, we also want a local load balancer that exists within our data center. Local load balancer, and this is a third layer of load balancer that will now determine what server to direct the request to. Once again, same process here. You decide what kind of algorithm you want to utilize. Once we get past that, we're going to hit our API gateway. API gateway. And here we will now start directing the requests based on the nature of those requests. Okay, let's start off with the simplest one. We're going to come over here and we're going to post a tweet. The tweet is going to hit the load balancer, and then the global load balancer will pass it on to the regional load balancer. The regional load balancer will pass it on to a specific data center. That data center will in itself have a local load balancer, which will determine what server to hit. And then what we're going to do is pass that request on to a tweet service. And this tweet service will first check and apply maybe some policies to this. Make sure that it definitely filters out spam potentially. Maybe it wants to, we have a spam service here that checks for spam. So we're going to hit this, and we're going to do a quick verification here to make sure that it doesn't break any sort of rules and isn't any sort of spam. And if so, and if everything looks good, we're going to pass this on to a message broker. We're getting hundreds of thousands of requests, every few minutes, and we have to make sure we can handle those. And the best way to do that is to use a message broker. I use Kafka. Over here we will have new tweet topic. So Kafka is a message broker. It means you send it tons of messages and it will store those messages. You're basically you are a publisher. You publish messages to the message broker to a specific topic that you've configured. Topics are designed to handle data from a specific service or a specific nature. You can configure it. Ideally, that's the approach. It doesn't necessarily mean that's going to be what's going to happen. And then you have you have services that subscribe to those topics, and read from those. So whenever there's a new message, they're going to read from that topic and then process that. So we're going to have tweet processor service. Over here, what's going to happen is we want to save this tweet into our database. So we're going to have two types of databases here. What is this thing here? Okay, it looks like if I have something selected. Okay, so we're going to have two types of databases here. One that contains the relationship between that holds information about user, who they follow, and things of that nature. For high volume things like the tweets itself and the likes, what we want to do is put those into a NoSQL database, because it's really important for us to be able to scale and manage those and be able to write them, and then allow us to collect a vast amount of different metadata depending on different types of conditions. So while we have structured data for user follower details, we will have a NoSQL, and we can, over here, we'll have a NoSQL database that will be tweets, likes, comments. NoSQL. And over here we'll use NewSQL. If you're unfamiliar with NewSQL, it's a newer version of SQL that tries to be scalable and be able to adapt to the new environment of cloud computing. Given that the volume in the NoSQL database will be significantly higher and it's a much more mature service, NoSQL server like MongoDB is ideal for scalability, especially when it comes to distributed system and when you're trying to scale horizontally. With that said, I realized that we are missing a very important information here, and that is user follower. So user ID, follower, user ID. And over here, if we look at our API, we want post user follow. We're going to have the access token and the user we want to follow. And then this will simply be a toggle. You'll hit the same API endpoint. If the data exists, it'll delete it. If it doesn't, it removes it. Actually, this might create some inefficiencies. So you know what, let's just keep it. Maybe you want to create one that's specifically for unfollow and follow, but because you'll be adding a condition in the functionality over here, we'll just go with this. But if you want to hyper optimize, definitely create two different API endpoints. So we've just processed the tweet. We want to save it to our NoSQL DB, and then we also want to definitely want to start utilizing cache here. The types of numbers we're talking about here, it will be impossible for us to have that data come directly from the database. The load will be significantly too high, and the latency would be significantly faster than using a caching service such as Redis. Redis is an in-memory storage that allows you to save information there and retrieve it extremely fast. What we want to do is, given the nature of this system, I would encourage us to have dedicated servers for different categories. So we have one for user, one for tweets, and we can even have one for comments. Anytime that you add a component to your system, what you're doing is you're increasing the complexity, you're increasing the overhead, you're increasing the cost. And so the trade-off here is you create some level of fault tolerance and reliability by ensuring that if one service goes down, the others aren't impacted, and that allows us a bit of better uptime than we would have otherwise. So we have just posted a tweet. We've validated that's fine. It's been processed, and now what we want to do is save it to our Redis server here. So we've just hydrated that tweet into the our tweet Redis server, and then whenever you post something to the server, you want to give it different conditions, like a timeout, how long it stays alive before it is invalidated. You have to maintain your Redis, your caching service, because otherwise they'll get bloated and you'll have data that's not being utilized. So there's definitely something you want to do there. The other thing we want to do here is, I'm thinking maybe another Redis server that's basically followers. Server, and this will contain information about a user's followers. You could potentially combine these two, and so that's an option there. I'm just separating them so you understand what kind of information we'll be keeping in our cache. Now that will allow us to, let's see, what we wanted to do is post the tweets. That takes care of that. Now what we want to do is delete. Let me just make sure this is right. We've posted a tweet, we processed it, we saved it into our database, we've saved it into our cache, and it's now accessible. Okay, so all right, well, looks like I missed an important thing here. That is get tweet. Here we don't need an access token because it's going to be public, so it's just tweet ID. User tweet ID. Okay, that gets that for us. And then let's see, and get user. That will get so let's just, for that we don't need to worry about that because that is just granted, and it'll just cause some confusion here. So let's just deal with the delete function now. So we've posted to our delete API. That request is going to come in and it's going to hit the delete So what we're going to do, we're going to hit here, and we are going to immediately write to a topic here. This is another Kafka topic. We're going to write delete, and we're going to send back a request that we're assuming we're going to take the probability that this functionality is going to be successful. So we're just, as soon as we write to the topic, we'll send back a response saying the delete was successful. And then if it wasn't, the system won't delete it if the user goes back. But it's the probability of this not being successful is unlikely. So then what we're going to have a delete service here. And once again, given the volume, some of these can be consolidated. Absolutely. So we're going to be subscribing to the delete tweet topic. Here, what we're going to do is, it really depends if you want to do a hard delete or a soft delete. If you want to do a hard delete means I'm deleting the row completely. A soft delete means I'm simply updating the status of the tweet to be deleted so that it still exists in the system, but it won't show it on the front end. And I think what we'll do in this case, we'll do a soft delete. And then what we'll also do is make sure that we flush out that specific data point from the Redis server. So, and then there are other questions of, do you want to also delete the comments? Well, you don't really need to. Once you soft delete, the only way to access those would be through going to the tweet. All right, so that takes care of that. Next, what we want to do is like a tweet. Once again, same thing here. We're going to go like tweet topic. We're going to post a like. That API is going to hit directly right to this topic, and we're going to have a service that like tweet service that subscribes to this topic, writes to the database, and then also updates our cache. So let's just say it's in here. It's simply a counter that we can keep associated to the tweet. All right. And when we want to, so here what happens is the logic in this like tweet will determine if the like already exists, it will delete it from the database and invalidate it from the cache. If it doesn't exist, it's going to create it. So that logic exists in the service itself. Next, we want to do a comment here. And basically, we're doing the same exact thing here. We're going to have tweet comment ID. We're going to write to it. And then we're going to have a service dedicated to this. There might be an argument to be said to actually first, just like over here, we will have, let me just zoom out a little bit. We're going to have check comment service. The API will first hit the check comment service. It will then hit the spam filter service, validate that, ensure that the tweet is fine. The comment is fine. And if then, and only then, will it write to the tweet comment topic. And we will have the tweet comment service subscribe to this, write to our API, and also validate or invalidate, depending on if we're doing a delete or a post. And for the other ones, for like, so what we can do here, is make this generic, make it simply a like service. This is a delete service. And based on the information that's coming here, we will know whether we're deleting or liking a comment or a tweet. All right, so that takes care of like, comment, delete. And then we want to follow a user. All right, so when we want to follow a user, we will, let's zoom out a little bit more again. We will have sorry about that. We will have a topic here called follow topic. And then we will have a service called follow service. And the API will write directly to this topic. The follow service will subscribe to that topic, write to our SQL database, and then hydrate. Let's move this. Our follow Reddit servers. So now each user is associated with that. So let's just say, over here, let's do get user as well, user ID. Once again, we don't need an access token, it'll be something public here. All right, so that's taking care of follow and unfollow. The logic will know how to handle that. Okay, great. So then what we want to do is get a tweet. So we'll have another service called get tweet service. The API will send that information send the request to the get tweet service. The tweet service will get the Let me move this. Hang on. Let me move this down here. Delete that. So we will first need to get the user information. We'll hit the user Redis server. Then we want to get the user's tweets. We're going to get that from the tweets. And then what we want to do is also get the number of followers the user has. That would be saved here. Let me just say that this service, actually forget it. This would get the user information. I'm sorry, we're getting a tweet, so we're just gonna get the tweet information here. We're gonna get its likes and comments as well. So the tweet itself and the likes will come from this table. The comments will come from this, and the user information will come from the user Redis server. Now, if we hit those and we do not find them, we will definitely hit our database. Let me zoom out a bit more. And this database as well. This is if the data does not exist in our server. All right, that gets us our tweet. And then what we want to do is get a user now. So now what we do is we have a user. This user service will be passed the user ID. It will hit the cache hit the user Redis server. It will also hit the tweet for that hit the tweet Redis server, and it will also not necessarily there. We don't need to do that because you'll have to go to a tweet to see your comments. And it'll also get its followers from the follower Redis server. Now, if it can't find those, just like the get tweet, it will hit both DBs to get that information. This will go here. All right, so that takes care of that. The other thing we need to do is now generate a feed for the user, and we can have a new server that is user. Why is it over there? User feed server, Redis server. Let's just call it feed server. So this server will be populated with the feed for, let's just say we have an API. Actually, get feed. Okay, so now what we have is a generate feed service, and what this does is it generates the feed based on a variety of data. So the algorithm or the model that you use is based on the activity of the user. So it gets data from all these different data points. But most importantly, who you're following is obviously who you are following. In addition to creating new suggestions, it'll do some sort of crunching and then generate that information and populate it there. Now, this is a really expensive, it can be a really expensive process if it's simply a matter of getting the people you're following and getting their tweets and putting them in order. It should be straightforward. If you want to make it more advanced, it can be more advanced. That's really a business decision. So, something to think about on a business level. So these two, these two guys also hit the load balancer. All right, guys, that's it. I think that's it. Let me see. Timelines and personalized content feed. We've done that. Integrate image. Oh, geez. All right. So what we didn't do is take care of the. We didn't take care of the actual media files. So let's take care of that real quick. So as soon as you upload the content, it's saved into a temporary S3 bucket. This is basically blob storage where you will ensure that you have the content saved as soon as possible. It will also check that content. Your spam filter service can be advanced enough to check those. As soon as those are finished writing to the S3 bucket, we're gonna have a topic over here. Let's just move it over here. So as soon as those things are finished loading, what we're gonna do is write to this topic right here. We're gonna have a media processor. This media service will process that information, save it into long-term storage, S3, and you can categorize. You can have multiple of these. So I'll subscribe to this. As soon as it finds that there's a new media, I'll process it, maybe reduce its size to make it more web mobile friendly. It can have different resolutions, and then I'll save that information into the database. And then in addition to that, what we're now going to utilize are CDN servers. And CDN servers are content delivery networks that allow us to serve static content pretty fast. So the media service will write to this as well. And then when it comes to deleting, it goes through the same process. What we can do is have a new topic that well, let's keep delete out of here because it would require a different flow here, but this is what's going to happen. So when you get a tweet, you're going to get the URL for those media content, and then your client will directly, like your browser or your mobile app, will directly hit the CDN server for those static media files. All right, guys, that's it. That's all I can think of right now. Let's double check. All right, when it comes to scalability, 100% our database, they're going to be sharded. The key that we decide, let's just say the hash, some hash value of the user ID, and then all our databases are going to be part of a database as a server. They're going to be in clusters, and they will be distributed across multiple availability zones and multiple data centers so that there's redundancy and backups. There will also be, for our topics, we'll partition our topics so that we can have multiple consumers consuming from our topics. All our services will be built on top of an elastic infrastructure like Kubernetes. They will be configured to watch what the CPU or memory usage is, and for each Kubernetes node, it will scale the number of pods it needs up and down. In addition, if a specific node isn't enough, if a specific number of nodes aren't enough, the system will have a cluster autoscaler, which it means it will now scale the nodes, add and remove nodes, which themselves will be scaling up and down the pods. And then for our cache, we'll have multiple Redis clusters all over the world, redundancy, and we'll definitely, same thing with our Redis, we'll be partitioning the data so it's easier to get. And other than that, I think we should be able to address most of the needs that we have set out to do. All right, that's my take on it, guys. Please double check everything you see or hear in my videos. This was pretty complicated. Somebody might have a far better solution than I do, and I hope you enjoyed it. If you did enjoy it, or if you did learn anything, please take a moment to like, subscribe, and leave a comment. Thank you so much, guys. Have a wonderful day, and bye for now.